Hello everybody, how are you doing? Today we continue our work on linear algebra and we are working with so-called determinants. Last time you remember maybe that we were concerned with the system of linear equations, and we worked on system with two equations and two unknown variables. Okay, I remind you a little bit. So let's start our work today, and it's still about determinants and still about system of equations. So determinants of the matrices, determinants and of the matrices, and system of linear equations. Okay. So I remind you our previous work. So we had system of equations a11x1 plus a12x2 equal b1 and a21x1 plus a22x2 equal b2. So here we have x1 and x2 unknown variables, and a with indices 1 1 1 2 2 1 and 2 2. There are some factors, some numbers, or maybe even functions, and b1 b2 they are still numbers of functions. And to solve this system of equations means that we have to find x and x2 so that these two equations in the system of equations are satisfied, are turned. So it means that they turn into the equations, not equations, but the equality, into equality. And we had learned that this system of equations we have can turn into the matrix form: a times x equal b, so that a consists of factors of the given equations, x as a vertical matrix with x and x2, and b consequently b1 b2 b1 b2 coefficients. Okay, so, and we had that we can calculate x1 as a11 times a22 minus a12 times a21 is a denominator, and numerator consists of b1 times a22 minus b2 times a12 and x2 equal b2 times a11 minus what? b1 times a21 over a11 a22 minus a12 a21. We agreed that denominator a11 times a22 minus a12 a21, it is the determinant of the matrix A. Determinant of the matrix A equal, denotation of the determinant is a vertical. It's kind of a matrix, but instead of parentheses, it has vertical brackets, and it's A11, A12, A21, A22, and to calculate determinants we have to multiply. We have to use a cross rule. Some people say this rule, cross rule. We have to multiply elements along the principal diagonal of the matrix with sign plus. I denote here plus. And I use this black ink. We have to multiply elements which are along the inverse diagonal with sign minus. So I put here plus and minus. And since that we have something like A11 times A22 minus A12 times A21. It's a denominator. So what about numerator? Numerator is a determinant of the special ornament matrix. I denote it like B A, which consists of the instead of the first column here, you have to put matrix B. So it is B1, B2 here. And the second column is still the elements of the matrix A. A12, A22. So it's very easy to calculate that determinant of this matrix is B1 times A22 minus B2 times A12. If you compare with this determinant with the answer for x1 and x2, you can notice that it's exactly the same expression. So determinant of the matrix AB, I denote here, equal determinant. I still put here the same elements as the first column, and the second column I have to change by the B1, B2. And determinant of this matrix gives B2 times B11 minus B1 times A21. So you can notice that this expression is exactly the what? Numerator or the x2 expression for quotation for the x2, and now we have its formula. The very good and very simple formula for rules of the system of the equations here. Formula that for x1 we can calculate. I'm sorry. x1 we can calculate using formula. Look, x1 equal determinant of the matrix BA. I remind you that matrix B slash A we can construct from the A matrix if we remove the first column and replace it by the B matrix. Over determinant A. And x2 equal determinant AB, so we have to make the same operation, but we remove the second column of the matrix A, replace it by the matrix B over determinant A. By the way, we find that if determinant A equals 0, there is no root of the system of linear equation. And here we can phrase some new terms. Some people say that matrix A, the matrix A, is a regular matrix. Or said to be a regular matrix. I'm sorry, here X matrix if its determinant is not 0, doesn't equal 0, and A is a regular is an irregular matrix, if determinant A equals 0. So the first step, if you have a system of equations, you have to construct matrix A and B. You have to check if determinant A equals 0 or not. And after this, you are ready to calculate the roots of the equation, of the system of linear equations. Okay. So here I use some other ink here, green ink. This is formula for calculation, x1 and x2. Okay, and this is a criterion if the system of equations has the roots or not. There is no roots. Firstly, let's make an example here. Example. For example, we have something like example. I use the blanking. For example, 2x minus x1 minus 3x2 equal 5, for example. 5x2 equal 10, if you don't mind. So the first step, we have to define A matrix and B matrix. A equal the first one, element 2, the second minus 3. Here we have no x1, but it means that this element is 0 here, and 5 as the element, as a factor beside the x2 unknown variable. And B matrix is 5, 10 here. Okay, now we have two A and B matrices, and now we have to calculate according to our rule. Okay, firstly, the first one step here, we have to check if A is a regular matrix or an irregular matrix. So we have to calculate determinant of the A. Determinant of the A, it is 2 minus 3, 0, 5, cross rule, 2 times 5 minus 3 times 0, and it is 10. Very easy. So it is not 0, so A is a regular matrix. It means that the system of equations, the system has roots. Has solution, it's better to say. Now we can use the formula. x1 equal determinant b slash a over determinant a, and x2 equal determinant a slash b over determinant a. So x1 determinant b slash a is, instead of first column for a we have to put b numbers, 5 10 minus 3 5, 5 10 minus 3 5. So we have 5 times 5 minus 3 times 10, and we have 25 plus and we have 55. Determinant AB is 2 0 5 10, and we have 2 times 10 minus 5 times 0, and it is 20. So we have two roots, two numbers, x1 equal 50, according to this formula, 55 over 10. It is 5.5, and x2 equal 20 over 10, and it is just 2. So your work here is kind of home assignment. Home assignment here. Check if x1 and x2 turn the given system of linear equations into equality. This is your homework assignment. Very important thing. Very important. I will be very angry if you don't check this equation, if you don't verify these two numbers. Okay. I think they are pretty good for a system of linear equations with two equations. But what happens if we have 3 equations and 3 unknown variables? So I put here the common view of the system of equations here. We have 3 equations, x1, 3 unknown variables, a11 plus x2 a12 plus x3 a13 equal b1, x2 a21 plus x22 plus x33 equal b2. And the last one, we have 3 equations, 3 unknown variables. I'm sorry. Here we have x1 and x1 here. x2 and a my god. I'm very sorry. I have to write down one more again time because I have here x1 a21 plus x2 a22 plus x3 a23 and x2 a31 plus x1 x2 A32 and x3 A33 B3. We have the same situation. We can turn this one form into matrix form. A times x equal b. Matrix A equal consists of factors of the equations. They are A11, A12, A13. By the way, it doesn't matter what indices do you use here. It's easier because to use these indices because it enables you to compare with the matrix, because matrix, the principle of construction of the matrix means that you have with these two indexes as location of the elements within matrix. For example, A11 means that this number I don't know what this number, but this number is located in at the first row and at the first column. A21, A22, A23 here, A31, A32, and A33. B consequently B1, B2, B3, and matrix X here. I lost the order of these matrices, so anyway, it is X1, X2, and X3. And the question is, can we use the same formula as for matrices with as for the equations for a system of the linear equations when we had two equations and two variables? Yes, we can. So if you want to define x, I remind here I, you have to calculate determinant of the matrix. I denote like I here slash b over determinant A. Matrix AI slash b is a matrix A with column I replaced by the matrix P. So I think it's not worth to prove this formula here, but you can make it directly if you try to calculate rules for this given system of equations directly using the method of the substitution. I mean, you can substitute x1 from the first, for example, equations here through x2 and x3. Then you have to put x1 into the next one equations, and now you can express x2 through the x3. And after this, if you put x1 and x2 and into this last one equation, you can express x3 through just numbers, coefficients and factors of the matrix A and B. And after you have to make the backward substitution, and you can express all of these x1, x2, and x3 through numbers. And finally, you will have exactly this formula with these determinants. Okay, this is the formula. I'm sorry, I'm very knocked with these straight lines. Hardly can I say that this red frame is really perfect. And this one formula is named Cramar's rule. So Cramar's rule enable you to calculate roots of the system of linear equations through determinants, using determinants of the the matrix A and A with replaced column, Cramar's rule. But the problem is that how can they calculate determinant of the 3 by 3 matrix with size 3 by 3? This is the question. And next our lecture we'll work with 3 by 3 matrix and we'll try to calculate determinants of the 3 by 3 matrices.